Hi, today I've been working on one of these, a NuTone IM5006. This is the main board of an IM5006, and this board came out of a set that I repaired and rebuilt about 2.5 years ago. Story of it was everything worked fine, and the owner of it went out of town for a few days, and when they came back, there was a loud buzzing or humming sound on the system all the time. So he contacted me, we did some basic checks, didn't seem to be anything with the installation, and so I told him all you can do is take it out and pack it up and send it to me and I'll take a look at it. It's almost 4 o'clock in the afternoon and I started on this board this morning. It was right around 10 o'clock. I've got nearly 6 hours into it and I just now think I found the primary problem with it. This is a very complex board. It's one of the most complex NuTone intercom boards that they ever made. And what makes it complex is not just what's on this side, but what's on the other side. This is a hybrid board. So on this side, you've got all of the sort of normal, typical through-hole components that you would see on most circuit boards. However, if we flip it over, what you've got on this side, which you can see better this way, is a whole raft of little tiny miniature surface mount components. So through hole on this side, surface mount on this side. Now the majority of the surface mounted parts on the back side of the board are little tiny resistors, little tiny ceramic capacitors. There are a few, not too many, transistors. There's 2 power transistors here. There's a bodge right here of a big capacitor that's not relevant. This is a very complicated board to work on because of the way it was designed. Why was it designed this way? Because 5006s do a lot. And to get it all inside of a package that fits in the wall and not make it any bigger than it really had to be, this was the way they had to do it. You could never have a normal size set if all of these were through-hole parts. You would need probably 2 more circuit boards to make it all work. So what was the problem with this? Well, the fundamental problem with it was there was a short in the board. That's what it comes down to. This board has 2 separate and independent power supplies. One power supply is to power the circuitry on this board, and the other power supply is to power the remote speakers that are connected to this board. Each power supply powers different portions of this board, so it's 2 separate power supplies on the same board. The power supply that powers this board has 5 different power supply rails of different voltages. Each of those rails power small local power supply sections within the board itself. So you have 5 main rails and then you have another 6 sub rails. That makes it extra complicated. Beginning on this board this morning, it was easy to determine that the problem, the shorted rail on the board, was the 12-volt power supply, which is good because that's easy to figure out. It's bad because that's the most used power supply on the whole board. It goes every which way. You could literally take a red Sharpie, close your eyes, draw a bunch of lines all over the board, and probably hit 80% of where the 12-volt power supply goes. The only other clue which I found was that right here, these 2 pins are the pins where the antenna gets connected, and right on this side, which is really hard to see because they're really small, there are 2 little diodes, and these are little protection diodes for the signal that comes in through from the antenna. So the signal comes in into the pins, passes through the diodes, and then goes into the tuner section. These diodes are both shorted out. And that's a common thing that happens when a set like this gets involved with lightning. When you put the word lightning into any kind of problem with a board, because of the randomness of lightning, all bets are off as to where the problem may be, or how many problems they may be. If you have blown up components here, and you have a short on the board, and it's not this, it could be anywhere on the board. There's no way to know because lightning is random. It does what it wants to do. It damages what it wants to damage. And where do you go? Where do you start? Well, you start at the beginning. You have to work through it from the beginning. This is the 12-volt regulator, and it supplies 12 volts to the board. When this was powered up before I think I found the source of the problem, the short was drawing nearly 1.5 amps, which is about a half an amp more than what this can easily supply. This is a 1 amp regulator. So it was overloading everything, which means nothing worked, and that's where the hum came from. What you have to do is you have to start here and work forward, looking for where the problem may be. Now, there are certain things that are easy to do because you can sort of divide up the circuit into sections and disable portions of the circuitry by removing components. The goal is you have this big giant problem, and you have to narrow it down, looking for where the source of the problem is. As I did that, and I removed components to bypass sections of the circuitry and so forth, the short became somewhat less. Actually got it down to the point where it was a little bit under an amp. So we reduced it by about a third. Maybe it was close to 3/4 of an amp, but that was as low as I could get it by disabling circuitry on the board. And one of the things we never do here, which you'll hear people talk about doing sometimes when you do a project like this, is, well, you have to cut the traces on the board. And it's like, no, you never do that unless there's absolutely no other way, because then you physically altered the board and then you have to repair that also. And what you have to remember is we're not talking about just this side, we're talking about this side too, with all of these little tiny components on here that are all jam-packed together and very difficult to troubleshoot. So I made some progress on it, and then I got to the point where basically I ran out of good ideas. There was no more reasoning through it. And then you have to realize that the best, most productive way to go about this, even though it's a lot of work and it's not technically very good, but it's the best that you can do sometimes, is you have to one by one start just removing components. Because when you have a short like that, the way you have to look at it is you have to have a component that can withstand the stress and heat, usually, of having nearly an amp flow through it. Because whatever component is shorted, it is most likely either like an integrated circuit that's shorted internally, or some other component that's shorted to ground. So when you have a short to ground, it's like a dead short like this, two wires with electricity touching together, where you get the spark where you go like this, something like that. So you need a component that can withstand the load of an amp without smoking. Now, there were no burned components. There was nothing. Even these two little diodes down here that are shorted out from the Lightning, they don't show any signs of physical damage. They're just shorted out internally. Visually, everything was checked, 100 times to look for something that was blown up. There wasn't any. One by one, I began to remove components from the board. And every time a component was removed, the board was powered up again, so I could see if we were making any kind of progress, or if by eureka we found the one that was shorted out and the short is gone. Since we started here with the fundamental power supply, this is the other heat sink. This sits here, and the regulators on this heat sink are for the other power supply on the board, and that's not really relevant to what we're working with. So that was removed. These were checked just because, and taken out of the way because it made it easier to work on the rest of the board. This heat sink actually has 3 voltage regulators, since this is the only one that was involved with the problem. The other 2 were removed and checked and then put aside. Also, the amplifier IC goes on the left-hand heatsink. It goes here. That was taken out just to get it out of the mix, because what you have to do is you have to one by one eliminate possible problems, because at that point I was still unclear and had no idea where the actual cause of the problem was. Since we had blown up diodes down here, it made sense to me, in looking at the schematic and reading the service manual, that it is possible that something in this area, which is the tuner section, could have been shorted out from the Lightning, because you can imagine Lightning comes in here, zaps the diodes, maybe makes it past the diodes into this section and blows up something. The tuner module was removed. It goes here. And then this integrated circuit, this one, and this one were all removed, as were local regulation, which is here, other small voltage regulators. This one was removed. This IC, which is for the cassette controller, it was removed, and there's a power transistor here. And then these are pass transistors. These go here. And these have to do with the second power supply, which we're not really dealing with. So this was removed just to get it out of the way, because it makes my life easier. And then basically no real improvement. There was a moment where I thought when we removed this IC that all of a sudden the short was gone, but then it turned out that where I had the board hooked up to my power supply, one of the leads snapped off where it's connected to the terminal block, and it wasn't powering up, so that was a false flag. And then simply started here and removed each integrated circuit one at a time until they were all gone, till they're all off the board. That's what all this is over here, and I'll show you that in a minute. At that point, nothing good had happened. It was the same. It isn't to say that some of these may not be bad. We don't know yet, because until you put things back, you don't know. So after that, I flipped the board over to work on the other side, and this is really hard to show, but I replaced, find something to point with here. There are little ceramic capacitors here and here. There was one up here that I already put back. There was two down here that I took off and put back, because these are capacitors that connect voltage to ground. They isolate it, but there's capacitance across it. If those go bad, then it's a short to ground, and that was kind of the problem I was looking for. That didn't cause anything good to happen. And then again, visually inspect, visually inspect, visually inspect. Can't find anything, can't find anything, can't find anything. So then I went on to the next most logical step, which was, if you have something that's withstanding the current of an amp flowing through it, that's going to get hot. So what you do is, I powered up the board, I let it run for a few minutes at nearly an amp. Yes, it is a dicey thing to do, but all of the most sensitive components have been removed. So how much worse could it possibly get? After you let it run for a while, then what you do is you take some alcohol, like this, and you spray different sections of the board. Not a lot, just a little bit to make it wet. And then you watch very carefully and you see where it stays wet and where it evaporates really quickly because it's hot. There seemed to be some heat in this area, but there's not really much of anything there. And then I realized, because you have to remember, this is like hour 4.5 now. Then I remembered there are these two big 5-watt resistors, one here and one here. These are 5 watts because they dissipate a lot of current, and that's why this side of the board got hot. So that was just one of those things. That's what happens when you get tired, you know, and you're tired of working on it and you've been fighting it all day and it doesn't feel like you're getting anywhere. When I sprayed this section over here, you know, I sprayed an area about the size of a silver dollar, and there was an area that the alcohol went and disappeared really, really fast, while around it, it stayed wet. So I did that 3 or 4 times to make sure. And then of course you do the next test, which is you put your finger on it, but you don't put your thumb on it. You put your little finger on it, because your little finger isn't all calloused up. Sure as anything, that was kind of hot. You know, it's like uncomfortably, like hold your finger on there for 4 or 5 seconds, and then you got to take it off because it's too hot. There was a little transistor which goes somewhere here, right here, and it seemed hot, so I removed that. That didn't change anything. It still was drawing nearly an amp. That could be hot because whatever the real problem was, pulling a lot of current through the transistor, and that's why it got hot, but it wasn't the source of the problem. So then I flipped it over. back on this side, and that side corresponds with this area. Now this integrated circuit had already been removed. These capacitors, the blue ones, these were replaced 2.5 years ago, and these are good quality, and that's not going to be the problem. You got some film caps, not really a problem. You've got a lot of passive components. There's just not a lot there. However, there is a diode here, and there's a diode here, and there's 2 diodes here. Earlier in the day, all the diodes were checked, and they all checked as good. So I discounted that at the moment. When I sprayed this side of the board with the alcohol, this area evaporated really quickly again. So right in here, where it's really hard to see, right there, there's a Zener diode. It's 12 volt, 1 watt, or 3/4 watt Zener diode, D35, and D35 was very hot. So I checked it again, and it tested okay. So I removed it from the board, because sometimes when you check solid state components like diodes and transistors, you don't always get an accurate reading when it's installed on the board. You have to take it off the board and check it independently so that you know whether it's good or not. And while it didn't measure as bad, it still was getting hot. Since it's a standard 12 volt Zener diode, I have lots of those, I went ahead and replaced it. When I replaced it and I turned the power supply on, the short seemed to be gone. That was good. I took a break at that point and decided that I deserved a nice frosty 7-Up, because who wouldn't think that was a good idea? So now when I flip it on, I'm going to flip it on here. I'm not going to show the meter because I don't want to move the camera. Now it's drawing almost nothing. It's just the needle bounces and settles back down to 0, which means it's pulling almost no current at all. And possibly the little Zener diode was the culprit all along. However, we don't know that for a fact. So what you're looking at are all of the components that were removed from the board during the troubleshooting. You've got all these integrated circuits. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 integrated circuits. There are 3, 4 other voltage regulators, maybe 5, 6, 7 voltage regulators. There's a couple little capacitors because they were just in the way. This is a MOV for surge protection. These are some film caps, the amplifier IC. You've got the tuner module, you got the pass transistor assembly, you got the other heatsink assembly, all of this. So what has to happen now is each and every one of these parts has to be put back onto the board. And as each part is installed back onto the board has to be powered up, and you have to check to see if you have any damaged components. Because remember, while we did find the primary source of the short, which was the Zener diode, because we possibly have lightning damage, we don't know if any of these parts are damaged also, because this problem with the diode would have masked problems with the other components. Because remember, as I went through and removed components looking for the short, the level of the short became less and less and less and less, which leads me to believe that some of these may be bad. Now, one of the things that I do is, for instance, this one, 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 that one, this one, not those, not that, these 3, these, not that one, and that one. Those are all parts that will get replaced with brand new parts, because I have them in stock and they're not expensive parts, relatively speaking. And if I'm going to go through the trouble of replacing them, there's no reason to put back old parts on the board. If it is lightning damage as part of the source of all of this, then it makes more sense to put new parts, because these parts may have become stressed from the lightning. We don't know that, but it's likely, or could be, and I don't want to see this set again for like 15 or 20 years. All of these will get replaced. These will get replaced. These have already been replaced. This one, this one, this one. These are very specialized. This one I may have. These two I don't. So what I might actually do is see if they're available or not, because you have to remember this is a model that came out in the late 80s. So some of these ICs are hard to come by, and I may have to order these two. The tuner module, probably what I'll do, because you can't buy tuner modules like this, they're not available anymore. I may rob one off another board and swap it out just because. Pass transistors will be fine. These are voltage regulators. These will get replaced, as will the other two on here, and hopefully in the end it'll all work. That's just a simple. There isn't really any point to this video that much other than to show a little bit about this is not as easy to do as people think sometimes. People sometimes ask me in YouTube comments, you didn't really show how you fixed it. Okay, this is how you really fix it. This is what it takes to really fix this. Can I teach you how to do this in a YouTube video? No. Not at all. One, it takes a lot of equipment to be able to work on a board like this because it's complicated. And two, you have to have a big understanding of electronics and be able to read schematics and understand circuit descriptions and be very methodical and. You can't just pick up a soldering iron at Radio Shack, even though there are no Radio Shacks anymore, and jump into something like this and have any hope of being successful. So I guess if I had to sum up this video all in all, I would have to categorize it as it's me ranting against this board. Because these boards are complicated. This is not the first time I've had to do this. And it's a complex board to work on. Complicated. It's just complicated. Just any way you slice it, it's complicated. When we last left off, I had the main board of the 5006 taken out of the set still, and I was preparing to go through and replace all of the integrated circuits and other components that I had removed from the board looking for the short. That got done, and in the end, there was this many parts, little hard to see, a lot of parts, that have to be replaced. All of the integrated circuits that were replaced on the board were replaced with brand new parts, and upon completing that, the short was gone out of the board, and I felt happy that hopefully most of the work had been done. However, things don't always work out exactly as you expect. Since the focus of the repair at that point had been entirely on the section, the power supply section that was powering the board which had the short in it, the second power supply on the board, which is the power supply that powers the remote speakers, which are connected to this connector down here, I hadn't taken a look at it yet. After the board was reassembled and the short was gone, now it was time to look at the other power supply, because in a lightning damaged 5006, it's not at all uncommon to have the second power supply also have problems because of the lightning. And if that power supply doesn't work correctly, then the remote speakers won't work correctly or at all sometimes. That's a problem, of course. It was indeed that the voltages here at this connector were incorrect or missing altogether. The secondary power supply also had damaged components. Now, fortunately, I've repaired a lot of 5006s with that problem, and I already knew which parts would be most likely the problem. Those parts were replaced, and this all came back to life and worked correctly. After that was done, it was time to put it all back together. So I put the main board back in the set, hooked everything back up, connected it to the power supply, turned it on, and indeed, there still was a short somewhere. Now, that short was, and there was also this really, really loud buzzing sound. The really, really bad buzzing sound had entirely to do with the chime module. This is the original chime module that was in the set when the customer sent it to me. This is blown up, and this is most likely unrepairable. These chime modules, this is actually a microprocessor. This has the tunes in it. It has a little program that runs over and over and over again, waiting for the module to be activated, and this is blown up, and there are no blown up components. It's just blown up, so this is not good. So this was replaced with another one. That got rid of the humming sound. However, it didn't address the new short that we had in the system. Now, the new short was not this board. This board tested out, proven, worked correctly, no shorts on the board, so that only leaves this board over here. This board is another complex board because it is a hybrid board, through-hole components on this side, surface-mounted parts on the other side, and which you can see here. Here's the top side of the board with all the through-hole parts, and here is the back of the board with all of the surface-mounted parts. Also, this board has not just one, not just two, but three microprocessors. Actually, this one's a microcontroller. These two are microprocessors. One of them, I think it's this one, controls the cassette deck. believe it or not, because it's a very complicated cassette deck. And this one is for intercom functions. Along with that are all of these parts down here, which are the parts that do the heavy lifting when you make an intercom call on the system. All of this up here is power. Some of it's power for the remote speakers. It's the door speaker communication. It's the chime input door speaker volume. This is all analog-y stuff up here. Not too terribly complicated. When there's problems in this section of the board, it's relatively easy to fix. However, down here, not so much. One of the problems with this board is this is a very poorly designed board in that all of these integrated circuits here are all through-hole parts, and the traces that connect to the pads that they're soldered to, which go through the board, and they go through both sides. So there's traces on this side and traces on this side. These traces are ultra skinny, and it's very, very difficult to remove these safely without pulling the traces up off the board. This board is a complete pain in the neck to work on. The other problem with this board specifically is this is a board that came out of a set with lightning damage. And I'm pretty confident, I'm 90% confident that this problem on the main board, all the problems here, were lightning related because of the damage to the secondary power supply that powers the remote speakers. That's classic 5006 lightning damage problem. So this board also exposed to lightning damage. The problem with working on a board like this and spending hours working on it is that you can solve all the problems here and all the problems here. However, if you have a problem here or here or here, it's unrepairable. Well, these components could be sourced and it could be new ones could be soldered onto the board. These all have programs, they have firmware in them, and the new chips would have to be programmed with the correct firmware to make them work in a 5006. There's no way to do that. One, there's no provision on these boards. There's no header that you can connect a connector to and then plug it into a computer to offload, which you probably can't do because these are locked, offload the firmware or install new firmware into blank chips because the firmware doesn't exist. It existed when the boards were made. It was probably at the assembly house where these boards were manufactured. These chips would have been programmed in a programmer before they were put onto the board. I don't have a programmer like that. And also, again, there's no program. I'm sure somewhere in the archives of NuTone, there is programs for these, but they're not sharing and they don't care. The most practical choice at that point was I looked through all of the boards I have for 5006s and I found an exact matching board for the original board. There are 4 or 5 different versions of this board. The earliest ones are very different than the ones they made when this set was made, and you have to choose a board that's exactly the same version because this board and this board are like a matched set. You're not supposed to, and in some cases you absolutely cannot, mix and match boards to make up a set from different eras because it doesn't work. In the end, the replacement board was good. It came out of a donor set. Donor is a polite way of saying used because that's what's available. There are no boards available for any of this from NuTone. That hasn't been for a long time, and they were never really big on having boards for 5006s available because of all of the different mixtures of boards that went into sets from different manufacturing periods. So this is an exact replacement. It works fine. A Chime module was retrieved from our stock of Chime modules and it was rebuilt and installed in the set and everything was hooked back together, and I went ahead and hooked it all up. And here is our fully functional IM5006. This was a very lengthy and complex repair, and I did have a couple conversations with the owner of the set as the work progressed to keep him apprised as to what was going on. He was all good with the whole thing, and the project actually turned out really well. This was a more complicated repair than average for a 5006. Most of them have ordinary age-related problems, which we have a really good handle on the rebuild of, and that's all great. There's been a greater number of lightning damage sets. I have a couple more videos I need to make about other systems that came through here with lightning damage. Some of them unrepairable, and those will be interesting videos because they have damage that you don't see very often and not that I've actually seen much in the last 40 years. So not sure what's going on with the lightning this year, but it's been much worse than average. I hope you found this interesting, and perhaps for someone it will be be helpful. If it is, give it a thumbs up on YouTube because that helps us just a little bit. There'll be a banner right here that shows you how to subscribe. Go to our YouTube homepage, click on the bell, and when you click on the bell, click on it to receive all notifications, and every time we post a new video, you'll get a notification and you can watch it. That's all for today. See you on the next video.